Can everyone hear me okay?
Yes, sir.
Okay, perfect. So I think first of all, we have as an ecosystem a lot to celebrate this year, right? In 2022, in September, we had the merge, and after 8 years of Ethereum, the network, 9 years of Ethereum, the idea, and probably 3 or 4 years of very active development. Ethereum has finally switched over from proof of work to proof of stake. Yay! So this is a very big change to the Ethereum protocol. It required writing a huge amount of code, creating an entirely new client, change the consensus layer, changing over how the existing execution layer works to make it talk to the consensus layer. It required a huge amount of coordination, but fortunately, it happened very smoothly for users, right? From the point of view of a user, if you do the thing that you normally do and download the software update for every hard fork, and in this case, just do this one extra step of also downloading and running a consensus client, then you could just go to sleep before the merge, wake up after the merge, and everything works, right? And if you're not running a full Ethereum node, then you don't even have to do that, right? So it's a huge upgrade for Ethereum's functionality, but from the point of view of a user, it just basically looked like another day in Ethereum, which is a big success, right? That's generally the way that we want upgrades to happen. And there's a lot more upgrades that are going to happen, right? So there is the transition to scalability, what we call the surge. So that includes rollups. It includes the on L2, on L1. It includes the EIP 4844 and some other measures that try to increase the amount of data that is available on chain. The Verge, which starts off with the switch to Verkle trees. That will allow what are called stateless clients, right? Clients that can verify the chain without holding any state themselves. And then in the longer term, this basically means using ZK EVMs on layer 1, right? So that you'll be able to use a snark to verify an Ethereum block. The Purge, protocol simplification. So starting off with EIP 4444, so that clients don't have to store the full history, but then also going into trying to simplify the protocol, banning self-destruct as one of the top EIPs right now, and a few other things. Dealing with MEV, dealing with centralization risks, the Scourge, and basically everything else, including account abstraction, which is really powerful for smart contract wallets, including multi-sig wallets, social recovery wallets, wallets using different kinds of cryptography, and lots of other things. And this is the Splurge. So that's on L1. On L2, we've seen rollups, right? So another big milestone is that rollups this year are finally starting to hit this milestone that I call stage 1, right? So this is a set of milestones that I identified in this post I made on Ethereum Magicians last year, which is basically pushing rollups to try to actually have their proof systems, whether it's optimistic or ZK Snark or whatever else, on chain, and basically not just be multi-sigs, right? Because in our ecosystem, we have a lot of things that call themselves layer 2s, but actually are just multi-sigs. And at the time, basically all of the major rollups were, except for the non-EVM ones, like Fuel and Loopring and a couple others that I'm missing, were just all multi-sigs, right? They were working on proof systems, but they did not actually have them. And Polygon, as of the end of March, actually, has their proof system turned on. they do still have a multi-sig, but the multi-sig has a very high threshold. It is, I think, 6 of 8 with 8 very independently distributed participants. So it's basically a huge number of people, or like almost all of this group has to agree. I guess it's not a huge group of people, to be fair, but it's a diverse group of people, and the great majority of them have to agree to kind of override what the code says, right? And they have plans to kind of over time remove that mechanism as well. And other rollups are kind of following on pretty soon, right? So Arbitrum, I know, is like, I forget, either they're at this milestone by this point, or they're very, very close to it. And then Optimism and Scroll and Tycho and all of those are continuing to work on this as well. There's a team in the Starkware ecosystem, Kakarot, which is continuing to work on rollups. So rollups are finally kind of turning into really properly being real rollups, which is amazing. And we're hitting actual milestones here with actual proof systems on mainnet. Further work on privacy solutions. So there's Aztec, which is continuing to improve. Nocturne is doing stealth addresses. More and more groups starting to appear. Social recovery wallets. Argent has existed for years. Soul Wallet is actually based on ERC 4337, so it's like very pushing to be standards compliant and to be a kind of drop-in replacement for MetaMask, so that users they're not just using it as a wallet for spending, but actually to do all of their Ethereum interactions. Non-financial applications sign in with Ethereum. The recent interest in Web3 social networks. So a lot of things are happening on layer 2 as well, but there is an important way in which these things are not like the merge, right? So the nice thing about the merge, as I mentioned, is that in the merge, the user could mostly just go to sleep before the merge, wake up after the merge, and they get all the benefits of proof of stake. With a lot of these transitions, things are really not that simple right now. So the challenge is that it's not just some change at the protocol level that users and developers can forget about. It's something where users need to really actively think and change their behavior. Developers need to really actively think and change their behavior. And this is true at every level of the ecosystem, right? And in order to make users' lives as simple as possible and make sure that people actually benefit from the privacy transition and the scaling transition and the smart contract wallet transition, the ecosystem really needs to do a lot of work to make the solutions that it's building actually work for just basic workflows that users actually have. So very simple one, right? Just paying people, and a particular real world use case of paying people. Let's say, you ask how, you need to pay someone, you have to ask, how do I pay you? And this is exactly the sort of thing that ENS is for, right? And this could be an in-person conversation. This could be over, Signal or Telegram or whatever. If Bob just needs to quickly answer, that's what ENS does, right? Bob can just say, hey, I'm Bob.eth. And Bob doesn't have to try to speak this, complicated 40-character address, and Alice doesn't need to copy paste a 40-character address. It's just all very convenient, right? And the challenge is that this whole scheme is designed in a bunch of ways around the kind of existing layer 1 based and not very scalable and not very privacy preserving workflow, right? So everyone can publicly see all of the payments that Bob receives with Bob.eth. And they're in one address. They're basically doxed. They're tied to Bob as a person, And sure, this could be not his, passport name, but it's, connected to his social network. If Alice sends payments to Bob, then someone could like look at the social graph and determine, hey, this is Alice, and Alice is really close to Bob, and all of these things. And it's there isn't really a way to have the convenience of ENS and at the same time like have privacy right now. And then ENS also is something that is exists only on L1. Now you can obviously use ENS to store L2 addresses. You can use it to store Arbitrum addresses or whatever, but you can even use it to store Bitcoin addresses or IBANs for fiat banking if you want. But like Bob can't actually create an ENS name without sending L1 transactions. And today, registering an ENS name is like reasonably affordable. But I remember back in even 2021, when we were in the middle of a bull market and fees were higher, like registering an L1 name often cost like more than $50. I think sometimes even more than $100. And if we get back to those conditions in the future, it could easily be even more expensive, right? So in the whole point of the roll-up centric roadmap is that we expect people to live on layer 2 protocols, right? We expect people to be able to have entire lives on various layer 2 protocols without needing to kind of go down to L1 and send transactions to L1 almost ever. Ideally, we want it to be possible to never do things on L1. And, if L1, like the roll-up centric roadmap thing actually ends up happening, and if blockchains end up being super successful, then like we could easily see a world where every L1 transaction costs $1,000, right? And if we're in that world, then it's a lot of users are going to have no choice but to do things on L2s. So can Bob make an ENS name on L2? This is the first question. What if Alice and Bob are on different L2s? What if Alice is on Optimism, Bob is on Polygon? What if they're on multiple L2s? Like, what if Alice is on Optimism and Arbitrum, Bob is on Polygon and Arbitrum? Do we have some kind of set intersection protocol where Alice can first kind of automatically declare to Bob, hey, I exist in these domains and I have enough money in these domains, and Bob says like, hey, I have this one, or well, I guess he. Since Bob is setting his address, but like Bob might wants to declare, which L2s Bob is on, and then Alice figures out like, hey, I can pay Bob over here, over here, over here. Alice chooses one. Might we wants to have protocols that work like that? What if they're on? Like, can we try to use the facts that Alice and Bob will realistically probably be on multiple L2s to our advantage? And finally, how do we preserve privacy, right? So ENS on L2s, this is actually something that I complained about in some public forum posts, I think about 2 years ago. And to the ENS team's credit, they've done a lot of work with CCIP, or ERC 3668, and this is actually happening, right? So basically, what they're doing here is they have a mechanism where you can have a contract on L1 that owns domains, and then it can allow subdomains of those domains to be somewhere off-chain, as long as the contract specifies a way to verify it on-chain. Now, the reason why I say in alpha form here is because I believe, I'm actually not sure of the latest details. I remember at the end of 2022, this was only using basically signature verifications from a gateway. So you have to trust the gateway, and then signatures from the gateway get verified in the contract. And so it's not a trustless way to have domains on L2s. But if it's absolutely totally possible, and like it may well have been done already. So feel free to ask the ENS or Optimism team and check. But basically the contract on L1 could just be verifying Merkle branches against recent state on L2s, right? And so you can have domains on Optimism, and like there's this thing called OptiNames, and you can have names on Optimism. And basically, Bob would be able to register a subdomain of, in this case, ECC.eth, and register it and move it around fully on on the Optimism layer 2. But then, he'd be able to use it for other things. So it's not perfect because Bob would not be able to get like bob.eth, and Bob had to get like bob.subdomain.eth, but like maybe that's fine, right? And maybe that kind of opens up more namespaces and maybe makes some shorter names more accessible. Maybe there's going to be like 50 different names that are on Optimism, and we're going to do the same thing that we did for traditional domain names. And if like I wants to have an L2 domain name, then maybe someone's going to put like lik.eth on Optimism, and I'm going to be vita.lik.eth, and like people are going to do fun stuff like that. But we're getting there, right? So L2 transition for domain names is one of those things where, like, fortunately, we can report a lot of progress, right? Which is, I think, really good and really important. Cross layer 2 transfers, right? This is the other thing, which is, let's say Alice only has coins on Arbitrum, and Bob wants to get money on Scroll. Like, first of all, it should be automated and like possible for Alice to just like make that payment automatically from inside of her wallet. Like, Alice should not have to make extra clicks just to send the payments to Bob if Bob is on Scroll. Like, that whole process should be just done in the background. There are cross L2 gateways, like there's Hop protocol and there's a bunch of others, but like it's not standardized enough, in my opinion. Like, what I personally want to see is I want to see like a Uniswap style protocol for doing cross layer 2 transfers, like just between an L2 and L2, right? Now, obviously, you don't need a protocol if you're willing to go through L1, right? If you're willing to withdraw and then redeposit, then like you can just do it directly. But even when we have ZK rollups, you're going to have some period of time before you actually get a commitment to layer 1, and then you'd have to go back to layer 2, and then you'd have to pay transaction fees on layer 1, and for withdrawals and deposits, they're higher than for regular transactions, so it might cost $1,000, especially in some future environment where blockchains get used more often. So it's this is a challenge, right? And for cross L2 transfers, basically what these things do is they are kind of these marketplaces with liquidity providers where you can give the liquidity providers coins on the Arbitrum side, and then the liquidity provider gives the recipient coins on the Scroll side. It's not like, well, what I would love to see is like a Uniswap style protocol, right? Like, the nice thing about Uniswap is that it does not depend on specific third parties. It does not depend on servers. It basically is just nothing but a contract on a chain, right? And even smart contracts can talk to Uniswap. So what I would love to see is just like a very simple Uniswap style protocol, no governance, no third party dependencies, no anything, where just like, arbitrage participants can come in, users can come in, it can be called by smart contracts, and it's fully decentralized, and and we can just reliably expect it'll still exist in the same form 10 years from now, just like, Uniswap v1 still exists today. And if you want to use it, you can still go and use it. Stealth addresses, right? So this is an interesting use case. Basically, if Bob wants to accept payments to bob.eth without revealing to the world that all of the payments that Bob receives actually were received by Bob, right? So what a stealth address? This is a scheme that was originally invented in Bitcoin land, but it's extended to Ethereum land. Basically, the idea is that Bob provides on-chain a key that we call a meta address, or I guess the meta address is something that Bob can register it with bob.eth, or Bob can just directly give the meta address to whoever needs to pay him. And then that meta address allows Alice on her side to generate addresses that belong to Bob, and Bob can detect that those addresses belong to Bob, and Bob can figure out how to spend for those addresses, but no one except for Alice and Bob can determine that that address belongs to Bob, right? So from anyone's point of view, other than just Alice or Bob, this meta or this ephemeral address that Alice generates just looks like any random address. But from Alice's point of view, she's sending to it, and from Bob's point of view, Bob detects in the ephemeral pub key registry this ephemeral pub key. Bob does a calculation with all the ephemeral pub keys on chain, and Bob detects like, hey, this ephemeral address actually will if you generate it with this ephemeral string, it actually leads to an address that has assets, right? When Bob cannot see what all the ephemeral addresses are, but just the ones that belong to him. And if Bob finds one that actually has assets, then like Bob can actually spend it, right? So you can actually extend this really nicely with ZK snarks, right? So this is an interesting kind of different way to do stealth addresses. That is, it requires more complex cryptography than what happens here. Like this is all basically based on Diffie-Hellman, right? Like basically you have some generate address function of the ephemeral private key and Bob's pub kind of meta pub key, or the ephemeral pub key and Bob's meta private key, and then this is elliptic curve multiplication, right? Like little r times big M is big R times little m, here it's it's kind of much more generic. Basically, so imagine Bob has what I call a key store contract, and in the key store contract, Bob, like the whole point of this is basically just to store Bob's spending public key, and like this actually is not going to even need to be a traditional public key. It could actually just be a hash of the private key, right? Because we're not actually going to be using regular signatures because we're going to have a ZK snark, but Bob and Bob's key store contract is going to have some kind of commitments to Bob's spending key, and also the rules for changing the spending pub key, right? So this could be some social recovery system. Then Bob has a bunch of addresses, and you could even have, like, Alice could generate these addresses, right? Anyone could generate stealth addresses that belong to Bob, and Bob can generate these addresses for himself. And the way that anyone generates them is that anyone picks one of these like random salt values and then makes sure that Bob has the random salt value. And then basically inside of one of these stealth addresses, like here I have it drawn as though it's in storage, but like actually you could use create2 and you could basically set it up so that the address itself is just a hash of bstore in R1, right? So this could just be the address. And then when the spending logic, instead of checking in the storage, it just checks, like it just literally uses the address opcode to check what the address is. And then that's going to be a hash of bstore. Or like something that like some piece of data that's connected to bstore, right? Like you obviously, if you're using create2, like you don't want it to be literally created by the bstore, right? Like it would be created by something else. And then you would have like some commitments to bstore as an argument, and then like that would create an address, right? It would be like so, but the point is that it's a hash that like contains bstore somewhere in the hash chain, and then it contains like random data and other parts. So spending from any of these addresses requires a ZK snark that proves like several different statements, right? So first of all, the ZK snark has to prove that the prover knows what bstore is, and that the prover knows like these other R values that basically derive Bob's address from prove that Bob's address is connected to bstore. This is not a public link, right? If all you see is bstore in the address, you do not have any way to tell that this address is connected to bstore. And the reason why we need these random values is basically so that you can't have someone like look through all the key stores and hash them and like try to figure out what all the addresses are, right? So these are like 32 byte random values, and like you can't go through all of them, right? So the prover has to like proves in zero knowledge that the prover knows like what this address is. then the prover proves knowledge of a Merkle branch from a recent state root all the way to the spending public key inside of this key store contract. So the prover proves a Merkle branch that goes from the state root all the way down here. It has to be a recent state. Right now, this is like a Merkle Patricia tree branch. In the future, it'll be something better. And then finally, the spender has to prove that they know the private key that corresponds to the public key here, right? And as I mentioned before, like this doesn't have to be elliptic curves. This could just be a hash preimage. So spending requires this zk dark. And if you do it this way, then like you basically have complete separation between the spending logic and the addresses. And the really nice thing about this, right, is that this is social recovery friendly. Like you can have a stealth address scheme where you do social recovery over here. And if you do social recovery here, you're automatically changing the spending logic for all the stealth addresses. And because the spending logic is wrapped inside of a zk dark, nobody knows when the spending logic actually changed, which I think is beautiful. Social recovery, and there should be multiple L2s, right? So this is actually a real challenge that I had when working with the Sol Wallet team. Basically, you have an account on Arbitrum, you have an account on Optimism, you have an account on Polygon. If you want to change the key, do you have to like send a recovery transaction on all of them? Or could you do it in one operation? Another more subtle problem. One of the nice things that the current externally owned accounts kind of like address system lets you do is it lets you receive money even if you've never done anything on chain to register your address, right? Like, so if I off chain generate an address and give you the address, you can send me assets, I can spend those assets. Until I spend those assets, I don't have to do anything on chain. Now, how does this work here? Well, let's say you never initiated your account on Tyco, right? Tyco is another L2 rollup. You've never initiated your account there, and someone sent you assets on Tyco. Could you change the key needed to access those assets, right? Could you change the key needed to access an account that you never actually initiated? And with this scheme, if you make like this hash be inside, like actually just be the address, kind of, well, not like directly this hash, right? Like, as I mentioned, like it's some different thing. It's like a hash of something else, and then the address would be the create to. Then that you actually could do that, right? Because even for addresses that don't exist yet, when you spend them for the first time, the spending will have to contain a zk dark. The zk dark will have to contain be a proof of a Merkle branch, and it'll be a proof of a specific Merkle branch, which will be in one particular place, and that will have some pub key that you could actually change, right? Basically, key store address separation, but across domains. Your key store contract can be in one layer 2, and these addresses could be in totally different layer 2s. You could have your key store on Optimism, your addresses on Arbitrum, Kakarot, and Polygon, whatever else. Non-financial apps, right? This is kind of the last thing. So an app can generate its own key, and you can transfer the key to sign in across devices. The thing that I think we want to move towards is like, the Ethereum wallet being able to generate or at least change this kind of signing key. So Farcaster works this way, and I think they want to move in this direction. Sign in with Ethereum kind of does sort of similar things, but like, right, I think one of the challenges of signing in with Ethereum is to kind of become better at supporting signing in across multiple devices. And then the challenge is that like we want this whole ecosystem to support smart contract wallets and support layer 2s. And this should be totally possible. It's not too hard. Probably one nuance is from a privacy perspective. A lot of these non-financial things, they're moving toward trying to be more private and more ZK Snark based. And like here, really using the ZK Snarks for privacy, right? Like there are ZK Snark based identity solutions that the 0x Spark team and other people are working on and all of this stuff. And in this case, like if we talk about social recovery, there's like recovery of the wallet, recovery of control, and then there's recovery of encrypted data, right? And like these two are different because you can recover the wallet by changing the key, but to recover the data, you have to recover the key, which is a different problem. Recovering the key is like a more risky thing, right? And like, if you look at how Signal works, Signal's recovery process is like, well, you can recover your account, but you lose all of your private messages, right? And like for their use case, it's actually not that bad a trade-off, right? So it's application specific. Maybe you need a recovery strategy for encrypted data. Maybe you don't. Maybe recovery of encrypted data is like less is something that can accept more risk of data leakage than recovery of control. Maybe not, and like it's very application specific. So conclusions are, I think, scaling is happening. The L2 transition is happening. Privacy is happening. It's definitely a long process, and there's definitely the whole regulatory rabbit hole and like trying to figure out the best way to handle that, but at the same time give people actual privacy. A lot of things to report on that, but that also needs to wait for like that will require its own whole presentation. Smart contract wallets are happening. The like Sol wallet has alphas that are kind of actually of the sort of MetaMask style browser wallet format, but the user experience needs to adapt to all of these things, and we need to make sure that like existing user workflows can actually properly and fully take advantage of all of this stuff, right? Like smart contract wallets, dApps all need to support ERC 1271, so they're smart contract wallet friendly. Privacy, like ENS addresses need to have some way of being privacy friendly. Scaling, ENS addresses need to be manageable on L2, right? Just like all of these little things. And I think, as an ecosystem, these are just things that we all need to, really be mindful of. And I expect this will happen. This will all happen because, we're finally seeing scaling not just be theoretical, but be a very practical thing. But it's something that like every developer, I think, really should start thinking of right now. So, okay, great. I see one question. L2 competitions are quite aggressive. What's my take on making them coordinate together? So I've actually been impressed by how much coordination is happening, right? Like there's definitely competition, and there's definitely like Polygon versus Scroll wars on Twitter and all of that. But at the same time, like lots of these projects are totally cooperating on ZK EVM design. Like Scroll and Tycho and others, they're all working together with the and even with the EF team on the PSC ZK EVM project. They're all there's lots of engineering level collaboration happening. There's more and more standardization level collaboration happening. So on a technical level, I'm actually impressed by how much is happening already. And I think the more the conversation kind of focuses on the technical side, and the more that things can be positive sum. Another thing is like, I think if we can try to kind of limit some of the more harmful kinds of competition, which really happen on the marketing side, by just agreeing on more clear terminology, right? So I tried to do this with the stage 0, stage 1, stage 2 thing, and I tried to do this with the type 1, 2, 3, 4 thing. Like the type 1, 2, 3, 4 basically being about like how close you are to being a ZK EVM. And the more that we can kind of agree on like what doesn't count as this, what doesn't count as that, the less we end up having these culture wars of like, oh, this is what it means to be a ZK EVM, and our project is the real EVM, and their project is not a real EVM. And like basically, the more we agree on clear definitions, the more like everyone, like people have to push their energies on actually achieving the technical goal, instead of like trying to have the best marketing strategy to convince people that they are a real L2 when they're actually not, right? So, but even there too, like I'm optimistic. I think things are already much better now than they were a year ago, and I think they'll keep improving. Standardization for EIP 4337 and 5564 and some of the other EIPs. So for 4337, I actually think the long-term roadmap is going to be to start enshrining it in protocol more and more over time, right? So the whole kind of fully off-chain 4337 idea was to help it develop faster, but in order for it to fully benefit from censorship resistance and maximize the efficiency and all of these benefits, like I think it's going to have to become on-chain over time. But before then, like I expect it to be standardized across layer 2s first, and both Sol Wallet and other wallets are like, there's actually a lot of wallets that are starting to support it. So I think that's something that's kind of going to start to happen, slowly. I mean, the bigger standardization problem is like basically making sure that all the dApps support ERC-1271, right? So at least like signing can happen across all these things. I mean, honestly, like the dApp level support for different wallets is like terrible right now. And like there's just lots of things that just don't even work with the Brave wallet, right? Like, guys, stop assuming everyone uses MetaMask. Like, if everyone just assumes everyone uses MetaMask and like assumes really tiny details that are around how MetaMask works, then we're not going to have wallet competition and we're just not going to have progress, right? So I think being much more standards compliant. If you are building a dApp, have some of your testers use Brave Wallet, use some of the ERC-437 wallets that are coming out, and like make sure that you're actually compliant with all that. That's a standardization problem that does really need to be solved, right? And then for the ENS on L2s, obviously, finish kind of rolling out actual Merkle branch verification, so we can actually have a trustless implementation, and we have multiple providers, so it's not based on one provider URL, and we have a huge number of providers that people can fall back on if the first provider doesn't work, all of these different things. So I feel like it's things are going in a good direction, but there's definitely a lot more work that like application and wallet developers can do. No, thank you guys for listening. I mean, hope all of you guys are having gonna have a great time for the rest of the day.
Thank you, Vitalik. Hope to see you next year in Taipei. Thank you.
Absolutely.